Have you ever been in the middle of a workout and just wondered, what is actually going on inside my body right now? Why is my heart pounding out of my chest? Why am I so out of breath? And what is that burn in my muscles? Well, today we're going to pop the hood on the human body and really get into the science of exercise. Let's dive in.
So think about this for a second. An all-out, flat-out 100-meter sprint feels completely different from running a long, steady marathon, right? One is this insane, explosive burst of power, and the other is just a grueling test of endurance. And that difference, it's not just in your head. It's because your body is literally using two totally different energy systems to get the job done. Yeah, the best way to picture it is that your body has two different engines. You've got one that's built for the long, steady haul, and then you've got this turbo booster for those short, really intense efforts. We call these the aerobic and the anaerobic energy systems. And honestly, understanding how they work is the key to everything. So what's the big deal? What's the main difference? Well, it all boils down to one single crucial element: oxygen. You see, aerobic literally means with oxygen, and anaerobic means without oxygen. And that one little thing changes everything. It decides how your body makes energy, how long you can keep going, and what's happening deep inside your muscles at any given moment.
Okay, let's get a little nerdy and look at the actual reactions. With aerobic respiration, your body takes glucose and oxygen and creates a ton of energy. And the leftovers? Just harmless carbon dioxide and water. But when you switch to anaerobic respiration, you're burning that glucose without oxygen. You get a super fast burst of energy, but there's a catch. The trade-off is a nasty byproduct called lactic acid, and we'll get back to that later.
So, your aerobic engine, that's your endurance machine. Think long bike rides, marathon running, a steady swim. It's incredibly efficient. It can just keep you chugging along for hours because your body has plenty of oxygen to meet the demand. It's your steady, reliable, long-haul power source.
And on the flip side, you've got the anaerobic system. This is your power boost. It's for those super high-intensity, explosive movements that are over in a flash, like a deadlift or a full-on sprint. Your muscles are screaming for energy faster than your heart and lungs can deliver oxygen, so they have to switch to this rapid-fire but very temporary source of power.
Of course, no engine can run without fuel. And just like a high-performance car, your body uses different kinds of fuel for different jobs. Let's take a look at how this connects back to our two engines.
Your two main fuels are carbohydrates and fats. Think of carbs as your high-octane, fast-acting fuel. They give you quick energy for pretty much any activity, aerobic or anaerobic. Fats, on the other hand, are more like a slow-burning diesel. They're a long-lasting fuel source used mainly by that aerobic endurance engine.
So when you eat carbs, things like pasta, rice, bananas, your body breaks them down into glucose. This stuff is your body's premium, ready-to-go fuel. It gets stored right in your muscles, all set to be burned for that instant burst of speed or power when you need it.
Now fats, they're your body's strategic energy reserve. They provide this slow, super steady release of energy, which is absolutely perfect for those long endurance events. This is exactly why marathon runners spend so much time training their bodies to get really good at burning fat for fuel. It's the stuff that gets them across the finish line when all those quick-burning carbs are long gone.
Okay, so we've got our engines, we've got our fuel, but what about that feeling the exact moment you start moving? That pounding in your chest, the heavy breathing. Let's break down what's happening right at the start of a workout.
The second you start exercising, your body just kicks into high gear. Your heart rate speeds up, you start breathing faster and deeper, and your heart physically pumps more blood with every single beat. Your muscles heat up as they burn through fuel. None of this is random. It's a perfectly coordinated response to get your muscles the energy and oxygen they're suddenly demanding.
Your heart rate climbs almost immediately. And why? Well, it's pretty simple. Supply and demand. Your working muscles are basically shouting for more oxygen to make that aerobic energy, so your heart has to beat faster to rush that oxygen-rich blood right where it needs to go and fast.
And it's not just the heart working alone. Your whole cardiorespiratory system, that's your heart and your lungs, they start working together in perfect sync. Your lungs pull in deeper breaths to get more oxygen, and they work overtime to get rid of the waste product, carbon dioxide. It's this beautifully efficient delivery and cleanup crew, all working to power your movement.
All right, but what about that burning feeling you get during a really tough workout? And why are you still gasping for air even after you've stopped? It all comes down to something called oxygen debt, and it's basically the price you pay for using that anaerobic power boost.
Remember that nasty byproduct of anaerobic exercise we talked about, lactic acid? Yeah, when you're working so hard that your body just can't keep up with oxygen delivery, this stuff starts to build up in your muscles, and that is what causes that signature muscle burn and the fatigue that eventually forces you to slow down.
So this little molecule right here, this is the guy responsible for making your legs feel like they're made of lead after an all-out sprint. It's your body's built-in safety switch telling you, hey, you've gone past your aerobic limit and now you're in debt.
So, how do you pay back this oxygen debt? Well, once you stop the intense work, your body needs a bunch of extra oxygen to break down and clear out all that lactic acid that built up. And that is exactly why you're still breathing heavily for minutes after you stop sprinting. You're just taking in the oxygen you borrowed to pay back the debt.
Now, those short-term effects, they can feel pretty tough. But this is where the real magic happens. Because over weeks, months, and years of consistent training, your body goes through this incredible transformation. It adapts, it becomes stronger, more efficient, and way more resilient. And the long-term results are just amazing. Your bones actually get denser. Your ligaments and tendons get stronger. Your muscles grow, that's called hypertrophy. But maybe coolest of all, your heart and lungs get so much more powerful. Your resting heart rate actually goes down because your heart becomes so strong it can pump way more blood with every single beat.
This whole process of your heart getting stronger and bigger, it has a name, cardiac hypertrophy. And it makes perfect sense. Your heart is a muscle, right? So when you train it, just like any other muscle, it adapts by getting bigger and more powerful. It turns into a seriously efficient pump, and that is easily one of the greatest health benefits of exercise.
So think about it like this. Every single time you exercise, every time you get your heart rate up, you are literally training your heart to be a better, stronger version of itself, a more efficient engine that's working for you 24/7.
And hey, it's not just about getting faster or stronger, it's about building a body that can handle more. As one of our sources puts it, things like jogging actually strengthen your entire structure, your muscles and your bones. And what that really means is you're way less likely to get injured, not just in sports, but in everyday life. You're building a more durable you.
So there you have it. We've seen that your body has two different engines, an endurance engine for the long haul and a power boost engine for those explosive bursts. We know they use different fuels, and we know how your body adapts both right away and over the long term. The only question left is, now that you know how your engine works, how are you going to choose to train it?